Hi there and welcome to PCM. In this video tutorial, we will be studying about logarithms. Okay, so let's start. When we write this thing, log n to the base a, this small a is known as base, is equal to x. It is read as logarithm of n to the base a is x. And what it meant? It meant a to the power x is equal to n, where there are several conditions for this to be a valid logarithm. That this small a, that is base, should be greater than 0 and should not be equal to 1, and also this number n should be greater than 0. Okay, so these two are points where if a is 10, if base is 10, then we simply write log n. We don't write 10 here as a notation. And if a is e, you know what e is? E is the Euler's constant or Napier's constant. It is an irrational number, just like pi. Its value is 2.7182. Don't actually need to remember this, but remember this ln thing. We write this thing log n to the base e as simply ln n. So we can note that first, log of 1 to any base, any valid base that is greater than 0 and not equal to 1 is 0. Then log a to the base a is 1 for a valid base, because a can be written as a to the power 1, and for this thing a to the power 0 is actually 1. Okay, so just compare this thing with this thing and you can just write this log notation. Then log a to the base 1 by a is minus 1. Why? Obviously base is valid, because 1 by a to the power minus 1 is actually a. Okay, so some important values we should that you should remember are log 2 to the base 10 is 0.301, and log 3 to the base 10 is 0.4771. Then ln2, you should remember this one. ln2 is 0.693. Then ln10 is 2.303. You don't need to remember as many, just 4 of these are good only. Okay, now some examples. First, log 4 to the base 2 is 2, because 4 can be written as 2 to the power 2. Then log 3 to the base 3 is 1, as 3 can be written as 3 is equal to 3 to the power 1. ln e is equal to 1, as if it is ln, then it's basically log e to the base e. Okay, so e can be written as e to the power 1. Then log 1 to the base 10 is actually 0, because 10 to the power 0 is 1. Now we move on to properties of logarithm. These are very important as it is asked and used in every question. So number 1, log of m dot n. M dot n is actually m into n to the base a is log of m plus log of n, obviously to the base a, and a should be a valid base. Let us understand this with an example. So log of 4 into 16 to the base 2 can be written as log 4 and plus log 16. Why? Because log 4 is 2 and log 16 is 4, so it is 6 here, and we know that log 64, 4 into 16 is 64, log 64 is 6, as 2 to the power 6 is 64. Hence it is verified and we can prove it. So here's a proof. Suppose let log m is x and log n is y. So m can be written as a to the power x, n can be written as a to the power y. Then multiply m into n, we get a x plus y, a to the power x plus y. Then this can be written. Then just convert this thing into the logarithm equation and replace x and y from here. Okay, so it is good. Then we have second property, which is just a modification in the first one. It is saying log m divided by n to the base a can be written as log m minus log n. Okay, so its example can be log of 27 by 3. We know 27 by 3 is actually 9, and log 9 to the base 3 is 2 from this side. But if we apply this property, we can write this thing as log 27 minus log 3. Now log 27 to the base 3 is actually 3, as 3 to the power 3 is 27, and log 3 to the base 3 is 1. So we are getting 2 here and 2 here. So it is a valid property. Its proof is similar to this one. You just have to replace here with a minus sign, and it will be divide instead of multiply. Okay, so you can do that. Then we move on to the third property. So it is saying log m to the power b to the base a is actually b into log m base a. So with an example, log 4 square to the base 2 can be written as this 2 can be placed here. So 2 here, then rest part is here, this thing, log 4 to the base 2. So we know that 4 square is 16 and 2 to the power 4 is 16. Hence this log is 4. And from this side it is also coming 4. Hence this is a valid property. So its proof is easy. Just always let one of the thing x and prove it. So in this case we take log m to the base a equal to x, then m can be written in this form, then raise m to the power of b, multiply b here, then simplify it in the log notation, and we will be getting the final answer by replacing this x from here. Okay, so in the this is the fourth property. It is also similar to third one. In this, the power is raised of base. So the base is a and it is raised by power b. So this b can be taken here 1 upon this thing, 1 upon b. So 1 upon b is there and rest log is same. So if we take log of 16 to the base 2 square, so this 2 can be written as 1 by 2 here and rest log is same. So log 16 base 2 is 4. So 4 by 2 is 2. From this thing RHS. From RHS it is coming 2. And from LHS 2 square is 4 and log 16 to the base 4 is also 2. Hence LHS is equal to RHS. It is a valid property. Its proof is similar to the third one. In this proof you just have to make a change in the power of a, not in the power of m, but in the power of a. Okay, so now we move on to the fifth property. So the fifth property is important. So it is known as base change property. This property says log m to the base a can be written as log m to other base b upon log a to the same base b. These bases should be same, and obviously these bases should be valid, i.e. b should be greater than 0 and not equal to 1. So if we have to take an example, log 81 to the base 9, we know that 9 square is 81. So if we directly we can write 2, but if we can change it in this way also, log 81 to the base 3. So in this case we have chosen common base to be 3. So this thing is 4 because of this thing, and log 9 to the base 3 is 2 because 3 square is 9. So it is also coming 2. Hence it is a valid property. Okay, so if we have to give a proof of it, always suppose log m to the base b is x, then it can be written in this form: m is equal to b to the power x. B here is common base. B here is common base. Then let this thing to be y. Then a can be written as b to the power of y. Then we can extract b from this equation by uh, uh, power by 1 by y. So we get b is equal to a to the power of 1 by y. Then we can add this b in this equation. So m is equal to b, which is a to the power 1 by y, to the power x. We get a to the power x by y. So if we take only these two terms, then we can convert this into this logarithmic equation, which says log m to the base a. This a is x by y, this x by y. So this is this x by y. So it can be written as log m to the base b upon log a to the base b. Okay, so you should be very thorough with all these 5 properties. And in the next logarithmic video, I will tell you about some other properties and its monotonicity, and I'll try to solve some important problems too. Read on.